to 200 level classes. Here we're covering 4 key topics. The first topic is wave propagation in linear isotropic elastic media. The second topic is about energy partition during the wave propagation. The third topic is a review of basic signal processing tools needed in geophysics studies. The fourth topic is about uniform wave field sampling, including the basic sampling criteria. Here is one of the key references used to develop this class. So, I will start with a man-made type of acquisition, like those used in oil exploration or mineral exploration. For example, here in marine, we make an explosion in the water. This explosion generates waves, which propagate into the ground. Each time the waves hit an interface, that is a physical contrast, or a change of physical properties like rigidity. Between two rocks, some of wave energy is reflected back to the surface, and some are transmitted to the deeper rocks. Then we record the reflected waves, which basically tells us about the structures and characteristics of the subsurface. So it helps us to understand the subsurface and the exploration of minerals and hydrocarbons is the idea that any sudden deformation of a portion of the earth generates waves, which propagate into the ground, and then we record the reflected waves, which are returning towards the Earth's surface at specific stations on the Earth's surface. Again, the recorded waves allow us to learn about the subsurface. Wave propagation. Here is one of the key references used to develop this class. Here is the plan we will follow for the first lecture of wave propagation. Let's start by looking at wave propagation. We consider a medium of piecewise continuous regions separated by interfaces, where the medium parameters, or medium physical properties, are discontinuous. When we make an explosion, a disturbance of a very short duration occurs at the point of impact. While the deformed area returns to its initial equilibrium, the disturbance gradually expands away from the point of impact. Let's watch. As illustrated here, the disturbance varies with time and position in space. The speed at which the wave moves from one point to another depends on the physical properties of the medium. This property, and others that we will introduce later, allow us to use wave propagation to probe media, even those as complex as the subsurface. Here is another example, a homogeneous media. Again, when we make an explosion, a disturbance of a very short duration occurs at the point of impact. While the deformed area returns to its initial equilibrium, the disturbance gradually expands away from the point of impact. Let's watch.